All right, 6.3 discusses trapezoids. We've already defined trapezoids. When you're looking at a trapezoid, how many parallel sides are there? There's two. It's one pair of parallel sides and that's it. Okay? So when you're looking at this figure, based solely on the fact that these parallel sides are going to be called bases, so you have base 1 and base 2. The non-parallel sides are called legs. So leg 1 and leg 2. And because the bases are parallel to each other, what do you know about these two base angles from opposite bases? What's their relationship going to be? Yeah, because SSI, because these are parallel lines, same side interior angles are supplementary. So if one angle is x, the other angle, the same side interior angle will be 180 minus x, or the supplement. Same is true over here. If this angle is y, then 180 minus y would be the other pair, or the other base angle. Okay, that's true for all trapezoids. Hey, it's true for all parallelograms as well, but when you're looking at trapezoids, be aware of that. In addition to this type of a trapezoid, you may also see a trapezoid that looks like this. Okay, so if you have a trapezoid in which the legs are equal to each other, that's really just a portion of what shape? What type of triangle? An isosceles triangle. So the name for this trapezoid is based on that relationship. If the two sides are equal to each other, you have an isosceles trapezoid. Now, because this is isosceles, what would you expect for the base angles that are on the shared base or on the same base? What's the relationship between those angles? They're equal. So in an isosceles trapezoid, this pair of base angles is equal. And this pair of angles from consecutive bases, or the opposite bases, are still supplementary. Okay. Is this upper pair of base angles going to be equal as well? Yeah, for the same reason. Okay. So when you look at this, if you know that these two angles have to equal 180 each and these are the same, then these are going to be the same as well. Okay. So be aware of that. You will see a number of figures that are in this shape, an isosceles trapezoid. The other shape that you're often going to see in dealing with trapezoids would be something like this, with right angles. Is this even a trapezoid? Does it have one pair of parallel sides? Yeah. Because these two consecutive angles here, or these two same side interior angles, are supplementary, 90 and 90, you know that these lines have to be parallel, therefore you have a trapezoid. And it's very likely you're going to see something like this. If I gave you this information, is there enough information provided for you to tell me the total perimeter of this trapezoid? Yeah, I want you to see if you can figure out what is the perimeter of this trapezoid. And what if I start making some markings here? Often when you're dealing with trapezoids, regardless of what they or how they're oriented or shaped, you're often going to break them into rectangles and triangles, right triangles and 90-degree rectangles. So if you do that with this figure, and break it down, what do you know this portion of that base is going to be? 8. Opposite sides of a rectangle are equal. So here, this is a right angle and this is a right angle. Well, what kind of a triangle is cut off right here? A right triangle with a 45-degree angle, so 45, 45, 90. And if you know the hypotenuse of a 45, 45, 90, what is the shortcut for finding the length of each leg? Take the hypotenuse and do what with it? Divide by 2, multiply by root 2. So you get your length, this portion to be 5 root 2. That means this portion also would be 5 root 2, which means this opposite side of the rectangle 5 root 2. So now you can combine these. 8 plus 8 is 16, plus 10 is 26. And then 5 root 2 plus 5 root 2 gives you 10 root 2. And so here would be your perimeter as an exact answer. If it was on a quiz online, you'd find the decimal form of that. Okay, now what if I gave you a similar type of thing, but instead of giving you a nice easy number to work with, what if I gave you something like 35 degrees? Now, could you find it? You're still going to break it down, so we still have this side of 8. But we're going to have two measures here that we need to find. How can we find x? Any ideas? Nick? Good. So we have an angle. We have an adjacent side and hypotenuse. Adjacent and hypotenuse relates the trig ratio cosine. So we can find that by taking the cosine of 35, setting it equal to x over 10, and then solving for x. So we can multiply both sides by 10. So here's our length x. And we can do a similar thing for the y. For the y's, you could take your angle 35, you have the side opposite and the hypotenuse. Opposite and hypotenuse relates to which trig ratio? Sine. And so to find y, we would take sine of 35 degrees is equal to y over 10, opposite over hypotenuse. Once again, multiply by 10 to get your variable completely alone. And so here is your length y, which is equivalent to this side as well. So if you add 8, 10, 10 times the cosine of 35, and 10 times the sine of 35, you'll get your total perimeter for that figure. So again, that's all that you're probably going to see right now. But even when we get to areas, these same unique relationships are going to appear again.